Good morning, students. Welcome to the GPREC Center for Digital Education of E-Content Development program on the module Concrete Technology subject. In previous lecture, we have discussed lecture number 5, part 1 of fresh concrete. In today's lecture, we are going to be discussing the part 2 of lecture number 5, fresh concrete. So the workability is nothing but property of fresh concrete. So in today's lecture, in the part 5, we are going to be discussing on the topic that is measurement of workability. Okay, in the previous lecture, we have discussed what is a fresh concrete, what is a workability, so what are the factors will affect after manufacturing the fresh concrete. So those factors, everything we have discussed. Now we have to measure the quality of fresh concrete, nothing but the measurement of workability. It will be measured in the laboratory tests and also in the field test. So there are having some of the common types of tests will conduct in both lab and field. That is the measurement of workability concept. So what is that one? So one, slump test. Second one, compaction factor test. Third one, VB consistometer test. Fourth one, flow table test. And fifth one, L box test. Sixth one, funnel test. These are the different types of test will be conducted in labs and also in the field areas. In field, easily we can conduct this slump test. So that's why slump test is very common type of a test for any type of a concrete, and also easily we can measure the workability. Okay, done. So the apparatus we need to measure the workability of a fresh concrete, you people can observe here. So for the slump test, the apparatus we need, so slump cone and the tamping rod, next the base plate, okay, and also the scale. Next, for the compaction factor test, the apparatus we need, this is a apparatus easily we fixed in a laboratory, but for the slump cone test apparatus we can carry in lab and also we can carry in field also. Okay, next, Kelly ball test. So this Kelly ball test apparatus easily we can carry in lab and also in field method. Next, flow table test apparatus. Flow table apparatus. Next, VB consistometer apparatus. These two apparatus have available only in labs itself. Why? Because these are the very big very large apparatus that we can't carry easily to the field areas. Okay, done. So how can we refer the measurement of workability? There are having Indian standard codes. So the measurement of workability of concrete, the following Indian standards IS codes are used for measuring workability of concrete. That is that if you are conducting slump cone test, the code book is reference as IS, that is Indians as per Indian standard as per IS 1959 for all the types of workability test. So we can refer this type of a code book. Okay, next, first one, to measure the workability of a fresh concrete, we have to be conduct slump cone test. Any type of a test, if you are going to be conducting, first thing you have to do, manufacture of concrete. Okay, then only we have to follow the type of test. Sorry, concrete test. Nothing but workability test. What workability test? Whatever it may be, if you are going to be conducting slump cone test, you have to prepare the manufacture of concrete. If you are going to be preparing compaction factor test, first you have to prepare the manufacture of concrete. If you are going to be preparing flow table test, first you have to prepare the manufacturing of concrete, whatever it may be. To measure the workability of fresh concrete, there are having different types of tests. First thing, you have to be manufacture mixing of cement plus sand plus coarse aggregate plus water with addition of also any additive materials. Okay, then only we have to do the conductings of a test. In that one, the first one, slump cone test. The slump cone test is a best method we can conduct in field test and also in the laboratory test, and it is used to measure the workability and consistency of a fresh concrete. So the slump cone test, it provides a good workable, it shows a good workable of a concrete, and also it presents the good quality of a fresh concrete. Okay, next, what is the purpose to conduct this slump cone test? To check the uniformity of concrete mix and to control the water cement ratio and to assess the workability at the site conditions, and also it presents how much quality, what is the quality of a fresh concrete is there, like that. Next, what are the apparatus we need for the slump cone test? You people can observe, no? So slump cone, so this is slump cone was invented by the Abrams. Okay, first we have to take the observation part in our lab itself. So what is the height of a slump cone? That is 300 mm or 30 centimeters. Next, the top diameter of a slump cone is 100 mm, nothing but 10 centimeters, and the bottom diameter of slump cone nothing but 200 mm, nothing but 20 centimeters. Okay, slump cone observations. And next, tamping rod. This is a tamping rod. This tamping rod, it will be provided as like this. Okay, so at one side it will be having like a sharp edge, another side it will be having like a small curved shape. Okay, so with that sharp edge, like our pen or pencil, like that, no? So with that our sharp edge, we have to do the compacting process. For each layer we have to provide the 25 blows. Why? Because to reduce the air voids in this concrete. Okay, in this cone. Next, base plate. This is a base plate and measuring scale. Okay, done. Now we will see. First procedure. First, after preparation of a after preparing a concrete, place the slump cone on a clean and very level based plate and fill the concrete in the 4 layers or 3 layers with each layer of 25 times of tamping rod, which is used to reduce the air voids. So when the concrete was filled up to the slump cone, just level the top surface and later just keep your hands on the handle and slowly lift that slump cone within 5 to 10 seconds, and then measure the differences in height between the cone and the slumped concrete. Okay, I will mention in here. See, first place the slump cone in a clean and level based place and fill the 1 layer of concrete and do the tamping rod and do the compaction process with the tamping rod of 25 times of blowing, and finally for up to 3 layers. So up to the 3 layers after filling the concrete on the slump cone top surface and just to level the top surface, and finally 5th one, slowly lift that handle and check the slumped level. Check the differences between how much slumped concrete and the concrete which is filled in the slumped level. Finally, you will get you will get three types of slumps. So the slump range, the slumps will be have three types. One is true slump, second one is a shear slump, third one is a collapse slump. Okay, so if you have taken the water cement ratio nothing but 0.4, then you will get the type of a concrete is a stiff workable concrete. Okay, stiff workable concrete. And next, shear slump. For example, if you have taken the water cement ratio 0.55 or 0.5, so then some quantity of concrete it will be fell down. Okay, so remaining it will be placed like this. Okay, if you have taken the water cement ratio 0.6, nothing but the quantity of water increased, no, so what it will be happen, the concrete will be get collapsed like this. So when the quantity of water we have taken more, so then the slump value is the slump range will be changes. Okay, done. So like this, the measurement of workability conducted by the slump cone test. Three types of slump. So what are those three types of slump? True slump, shear slump, collapse slump, and also zero slump is there. That is very stiff. This is just stiff. This is very stiff. This is medium workable and this is highly workable. Okay, done. True slump, uniform subsidence, this is desirable. Shear slump, one side only it will slips and the other side it will be stands, lack of cohesion. Collapse slump, mixed too wet where the water quantity is taken more, so the quantity of concrete it will be fell down. Finally, we will get after the calculation, after taking the differences level, if you got the differences in between 25 mm to 50 mm, the type of a concrete will be used for mass concreting. If the range you got in between 50 mm to 75 mm, then it is the concrete is can be used for the footings. Okay, if you got the range in between 75 mm to 100 mm, then the type of a concrete is only used for beams and columns. If you got the range of slump value 100 mm to 150 mm, then it is only useful for the pumped concrete through the lifting of pumps itself. Okay, done. Next, second type of measurement of workability, compaction factor. This is some little bit different than the slump cone test. Okay, so the compaction factor is a laboratory test used to determine the workability of a fresh concrete, especially for low workability mixes, by measuring the degree of compaction achieved under standard conditions. Okay, this is an apparatus. It will be fixed in the laboratory. So it will be having two hoppers and one cylinder. So top hopper and bottom hopper, middle hopper and this is one is the cylinder. Same as it is when we have prepared that fresh concrete, the concrete is collected in a tray and slowly poured on the first hopper. So when pouring into the first hopper, we have to take one precaution. Here one small shutter is going to be presented. So first all the shutters are going to be closed and neatly that some oil or grease have to be applied for these hoppers inside the hoppers. So after filling that concrete up to the top level of a first hopper, just you open that shutter, what it will be happen, the concrete is transferred into the second hopper. Okay, so when it is transferring, previously the second hopper shutter it must be closed. Okay, so when the concrete was transferred from first hopper to second hopper, okay, then the quantity of concrete it will be taken in second hopper, the remaining quantity it will be fell down. Why? Because the dimension of a first hopper and second hopper is entirely different. You just observe here. What is the top diameter of hopper? That is 260. What is the middle diameter of top diameter of middle hopper? 240. Nothing but 20 mm it was difference, no? Next, okay, what is the height of top hopper? 280. What is the height of second hopper? 240. So when the measurements, when the dimensions are changed, so the concrete quantity also it will take, the remaining concrete it will also fell down. Next, coming to that, again you open the shutter of second hopper. What it will be done? The concrete which is presented in the second hopper easily transferred into the cylinder. What is the diameter of cylinder? 150. It was increased. What is the height? 285. It will get also changed. Okay, some little bit quantity it will fell down and some quantity, required quantity, it will be placed in cylinder. That is the concept of fresh concrete. But what the purpose? Nothing but placing of concrete in a specific locations we are telling, no? For that one purpose also we can conduct this compaction factor test. Now you see, the compaction factor test is a laboratory test used to determine the workability of fresh concrete easily for low workability mixes by measuring the degree of compaction achieved under standard conditions. Done. Purpose: to assess the workability of stiff and low workable concretes, to compare workability of different mixes, and to more accurate than the slump test for dry concretes, not for the very liquid or very semi-liquid concretes. It is only sufficient for the dry types of concretes. Okay, next, procedure, how I have to be done. Okay, just now I have explained the procedure part. First, place the concrete in the first hopper, then open the shutter, concrete will be placed in the second hopper. So again, the second hopper shutter you just open, the concrete which is placed in the second hopper easily transferred into the cylinder. So likewise, you just do the process for 1 or 2, 3 trials. So then measure the weight W1 and W2. What is W1? Weight of partially compacted of concrete. Okay, partially of compacted concrete in cylinder, which is transferred from the hoppers to the cylinder, no? That is partially compacted. We have to measure the weight, that is W1. Then what is W2? That concrete is fully placed in a cylinder in 3 layers. Okay, this is a cylinder. Now I will place in 3 layers. For each layer I am taking the 25 times of tamping rod. Compaction I am doing. So after filling that one, I am going to be measuring W2. Okay, now I will have a calculation part. So now, what is W1? Weight of a partially compacted, where it was transferred from hoppers to cylinder. Okay, that is partial. Next, what is fully compacted? Only concrete is placed in cylinder as 3 layers with 25 times of blow with tamping rod. Okay, now we have a small calculation. So W2 by W1 into 100. We will get some percentage. So finally, the range will be get. Okay, no need of doing the into 100. We have to get in points. Done. The workability range. If you got the compaction factor in between 0.7 to 0.75, then it is very low workable concrete. If the compaction factor you got in 0.75 to 0.85 range, okay, then it is then it is low workable concrete. If you got the range in between, if you got the compaction factor range in between 0.85 to 0.92, then it is medium workable of concrete. If you got the range in between 0.92 to 0.95, then it is high workable concrete. For our calculation, I got 0.67. Just I'm telling. Now, which type of a workable nature? Sorry. Now I have to be mentioned as per IS 1199 equals to 1959. So the compaction test is going to be conducted. So the final result I have got 0.67. It was referred by the above table. It is suited as 0.67 is in between. Okay, it is no more. So it will become under very low workable of concrete. It was not suited less than the very low. That means very stiff concrete it is there. Okay, for example, I got 0.81. So then in which workable of a concrete? 0.81 means done. 0.75 to 0.85. So the 0.81 is suited in 0.75 to 0.85. Then the type of a concrete, it will be set as low workable of a fresh concrete. Next, flow table test. Here also same. First you prepare the fresh concrete, then go for the flow table test. But when the flow table test, when we are conducting slump cone test, in the slump cone test there are having three types. One is a true slump, another one is a shear slump, another one is a collapse slump. If these true slumps and shear slumps, it will be get just to go for the compaction factor test. If the range of a slump cone test, if you got collapse, just to go for flow table test. So that flow table test only we are going to be testing. Flow table test means nothing but what is the flow ability of a concrete. Now we will discuss. The flow table test is used to determine the workability and flow ability characteristic of high workability concrete. Just now I have said, when the collapse range will become, when the water cement ratio is taken 0.6, water quantity is increased, workability also increased. Then the what type of a slump cone will be get? Collapse slump. When I am getting the collapse slump, then I will go for the flow table test. Don't go for the compaction factor test. No need, it won't be sufficient. So directly go for the flow table test. Now you see, the flow table test is used to determine the workability and flow characteristics of high workability concrete, especially where the slump test is not suitable. Okay, done. What are the apparatus we need? Flow table and slump cone. In this flow table, diameter will be provided. So in this diameter, this slump cone is going to be arranged. Same how that slump is going to be in that slump cone, how the concrete is going to be filling, same like that. Each 3 layers, for each layer 25 times of blowing we have to give. So after the lifting this slump cone, it will be, the concrete will be spreaded like this. Then measure the distance in both sides. This is the diameter. Then do the calculation part. Okay, now I will tell. Purpose. What is the purpose to conducting flow table test? Nothing but to measure the flow ability. Work ability is different. Flow ability means, okay, this flow ability of a concrete, where it will be works when we are placing in the reinforcement parts, or else when we are placing in the large type of for the depth deep beams. So it should be flow of a concrete very sufficient. Okay, if there is any harsh kind, it won't be flow, just it will be stay like that. Okay, when the concrete is placing in a specific location, it will be get slowly flow. How the water will flow? Very slowly, like that. Next, suitable for high workability and flowing concretes and used for self-compacting concretes and rich mixes. And the procedure: first, place the table on a level surface. Okay, this is the table, we have to be placed in level the press. Next, keep the flow mold, slump mold at the center of a table. Okay, and fill the concrete in 2 equal layers. If you are taking slump cone, fill the concrete in 3 layers and each layer is tapped 25 times and lift the mold as vertically. What will be happen? Slowly the concrete will get collapse and spreaded entire on the flow table. Okay, and measure the diameter of spreaded concrete in 2 perpendicular directions. Sorry, just this is one direction, you measure this one direction also, you measure. Okay, so both should be get nearby equal. For example, this is the diameter, for example you got 100 mm, this is the direction, you got 99 mm, no problem, just 1 mm was the difference, no problem for that one. Or else 101 mm, 102 mm, no problem. Okay, done. You just measure. Here the concrete was spreaded from the center. Then calculate the average flow diameter. How we have to be calculate? See, like this we have to be measure. After lifting that slump cone, so the concrete will be get collapsed and easily it was measured in this one direction and another direction. Finally, spreaded diameter minus 25 by 25 into 100. Then you will get one value. So that value, it should be suitable. If you got the value less than 30%, then it is a low workable of a concrete. If you got the value in between 30 to 50, then it is nothing but medium workable concrete. If you got the value in between 50 to 75, then it is high workable concrete. For example, how much we got here? 100 mm. So 100 minus 25 by 25 into 100. This is the spreaded diameter. Okay, while measuring this diameter, I got the 100. Now I am doing the calculation part. So 100 minus 25, 75 by 25. Now you get the calculation part. With 5 table. So 5 5s are okay, 5 2s are 0. Next 5 1s are 5 4s are. So 75, 20, 28, 29, 30. So 300, it is having more than high workable nature, like that it will be get. Okay, done. So it is more than high workable nature. Okay, for example, if you got 50, the spreaded diameter, then how? 25 minus 25, 50 minus 25, 25 by 25 into 100, 1. So which is 100, which is more than 75, like that. If you got 75, how much? 50 by 25 into 100. Okay, into 100. 5 5s are 5 10s are 5 1s are 5 2s are 200 it is getting. Oh, very too damn. Okay, so depends on the measuring, we will get the range of value. Okay, Next, the Kelly ball test. So the Kelly ball test is a field test used to determine the quality of or the workability of a fresh concrete by measuring the depth of penetration of a standard steel bar under its own weight. See, what are the apparatus we need? Steel ball. See, this is a Kelly ball apparatus. A handle is provided, a graduated scale is provided, and two frame arms are provided, and a steel ball. Very solid hemisphere ball is available. The diameter of a steel ball is 150 mm and the weight of a steel ball is 13.6 mm, and a graduated scale. The need of a graduated scale: when a fresh concrete was prepared and we have provided, we have taken into the tray, so then place this Kelly ball on a concrete like this. Okay, slowly what it will be happen, the ball it will be penetrate into the concrete. Finally it stops. Just mark the value. Okay, just mark the value. Okay, mark the scale, sorry, mark the value from the graduated scale. Then we will get the kind of quality of a workability of fresh concrete we will get. Purpose: to assess consistency and workability of fresh concrete, suitable for mass concrete and pavement works, and also simple on-site test also. Procedure: just place the fresh concrete on a leveled surface or else any trolley or any trowel process, and lower the Kelly ball gentle onto the keep the Kelly ball apparatus on a concrete member, and just release the hand slowly. That ball apparatus, it will be penetrate to its own weight inside the concrete level. So when the Kelly ball penetrated stopped, measure the depth of penetration from the graduated scale. Note the average value. See, if the penetration it was happen more, nothing but the greater penetration was happen, it is having the high workability level. If the lower penetration was happen, lower workability level of concrete it is presented. Next, VB consistometer test. So this is a apparatus VB consistometer test. The VB consistometer test is used to determine consistency and the workability of very stiff concretes. When we are preparing, if we have taken water cement ratio is 0.4. So the type of workable of concrete, it will be get very stiff. So for those very stiff type of a concrete, this VB consistometer test is going to be applicable easily. Okay, done. See, the VB consistometer test is used to consistency and workability of very stiff type of nothing but low workability of concretes by measuring the time required for concrete to change shape under vibrations. Okay, due to the vibration process, how the stiff concrete, how much time it will be take to settle in the specific location. Okay, done. What is the purpose? To assess very low workability concretes. It's suitable for roller compacted and dry mixes, and it is more accurate than the slump test only for the stiff concretes. How we have to be do? Procedure: first, place the slump cone inside the cylindrical container. This is a cylindrical container, and fill the concrete in 3 layers or 4 layers with 25 times of tamping of each layer. Next, lift the cone carefully proper. Okay, then place the transparent disc. This is a transparent disc. Place on the surface of a concrete, just switch on the machine. Due to the vibration process, the concrete will be slowly settled, and just record the readings, how much time it takes to settle the stiff concrete in a specific location. That is the VB consistometer test. It will be provided the time. So if it takes more than 20 seconds, that is a very stiff concrete, workable concrete. If it is taken 10 to 20 seconds, low workable of a concrete. If it has taken 5 to 10 seconds, within a 5 seconds it was settled, means medium workable. Okay, if it is less than 5 seconds, that is only high workable of concrete. Only for stiff concretes this type of a test, VB consistometer is going to be conducted. Okay, so time level, if it is taken shorter time, high workable concrete. If it is taken longer time, lower workable concrete. Okay, advantages. So accurate only for the stiff concretes. Objective measures, time based, suitable for the laboratory testings. Next, L-box test. L-box test is a best for self-compacting concretes. The L-box test is used to assess the passing ability and flow characteristics of self-compacting concrete when it passes through the reinforcement rods. There are having 3 reinforcement bars without having any segregation and blocking. Okay, done. Purpose. So to evaluate passing ability. So the concrete, for every type of a test, there is having different type of a nature. For a slump con test, good workability and quality. For Kelly ball test, workable nature and also quality. For the compaction factor test, what is the placing nature? For flow table, what is the flow ability and flow ability nature? And VB consistometer, nothing but what is the time taken for the vibration, only for stiff, like that for the L-box test. Okay, in between reinforcement steel bars, how the concrete will flow properly. The type of test we are going to be conducting as L-box test. So to evaluate passing ability of self-compacting concrete, to check the blocking effects due to the reinforcements, and to assess flow uniformity. First procedure, how we have to be do. So first, lightly apply a small apply a grease or any lubrication oil to this mold, inside the mold properly. Next, first close a sluice gate. This is a sluice gate where the concrete, it won't come outside. First we have to be close that sluice gate, then fill the concrete or allow the concrete in this vertical chamber. Okay, in this vertical chamber within a 1 minute, and just lift this sliding gate to get the concrete flow. So when the gate was opened, slowly the concrete will come here. Okay, slowly it will get slowly the concrete will get flow in between these 2 steel bars, and it will be settled. Just measure the differences, 3 parts. H1 is height of concrete in vertical section. H2 is height of concrete at the end of horizontal section. Okay, the L-box ratio, H2 by H1. If you got H2 by H1 is, which is equals to 1, the range is 1, then it is excellent passing ability. If you got less than 0.8, there are having blocking tendency present of L-box test. Okay, so finally this one, if you got the value in between 0.8 to 1, that is acceptable. Passing ability is acceptable. If you got less than 0.8, very poor in passing ability is there. Same. Okay, done. So thank you students. So today we have discussed how to measure the workability of concrete, and also flow funnel test also is there. Same like that only we are going to be conducting. Okay, so thanks for your patience for listening these concepts.